in lab today. This is another one of those experiments where we have multiple procedures going on to synthesize the same product. Oh, actually, before I forget, so we have a couple things coming up in terms of lab. So on Wednesday, you don't really have to worry about turning anything in because you have your exam on Wednesday. I'd like for you to focus on that. So that's just going to be coming in and doing the characterization of the DEET for Wednesday. Next Monday, we will begin experiment 13. Experiment 9, esters will be due here. So we'll push the due date of that back. And then this is also when you're going to have your experiment 11 quiz. Okay? So basically, I'm just trying to avoid you having anything to worry about on Wednesday because that is your exam day.
So Monday we need a pre-lab?
Yes, you'll need to have the pre-lab for 13 for that. Okay? And that's, experiment 13 is a 2-reaction sequence, so you really just need the first half.
So there's part A and
Yeah, there's a part A and B for experiment 13, but you just need to have the 13A prepared. Okay? Okay, then what you're going to do today is we're going to try to make DEET. So DEET is the active ingredient in a lot of the insect repellents, most notably the OFF type products. And if you take a look at DEET, you can see that it is actually an amide, right? And what kind of amide is it? Is it a primary, secondary, or tertiary? Yeah, it's a tertiary amide, right? So the way you're going to be doing this is combining, ultimately you're going to be combining the carboxylic acid with an amine. Now, the problem is you can't just take the carboxylic acid and put it in the presence of the amine, because if you do, it's just going to undergo an acid-base reaction, where the basic amine will deprotonate the carboxylic acid, and then you will sit with a ammonium carboxylate salt. Okay, no real substitution will occur. So what we need to do in order to make this go in terms of a nucleophilic substitution is we have to do what we activate the carboxylic acid. And we talked about a couple of ways of doing that. Probably the easiest way that we've talked about for the longest is by taking the OH group of the carboxylic acid and making it a Cl, turning it into the much more reactive acid chloride. All right? So that's what a couple of you are going to do. Those of you that have procedures A and B, that's what you're going to be doing, is just taking the carboxylic acid and making it into the more reactive acid chloride. Once you have the acid chloride, the amine can go in directly and do the substitution. Okay? So those of you who have procedure A, who is that? All right, so y'all are going to be using thionyl chloride for this. Now, thionyl chloride is something you kind of have to be a little bit careful with. If you are looking at your procedure, you know, all of you will be building kind of an apparatus. You don't really want to use thionyl chloride in the open air because it decomposes readily to give you HCl gas, which you don't want to breathe in, and sulfur dioxide gas, which you also don't want to breathe in because it stinks to high heaven. So you're going to build this kind of self-contained apparatus as described in the lab manual. You are going to ultimately be collecting your thionyl chloride, this is a liquid, in a syringe. And so I'm going to tell you something that you've probably never heard before, and if you work in healthcare, is going to make you cringe. But when you go and collect your thionyl chloride, and it's by about a half a mil in your syringe, I would like for you to cap the syringe. I know you're never supposed to recap a syringe, but I'm telling you, I would like for you to cap it. Number one, because as you draw up the thionyl chloride, if you just carry it back to your bench, it's gonna start leaking out. The thionyl chloride will start leaking out of a syringe, and that's the last thing we want being strewn across the lab. Number two, it's just a lot, because you are gonna be taking this back to your bench, it's a lot safer to have people walking around with capped syringes as they walk back. I will never forget the first time I did this experiment. I didn't have people recap, and I had swarms of people walking around with uncapped syringes of thionyl chloride like they were going to a knife fight, and it was just mortifying. So I would like for you to recap your syringes, even though I know you're not supposed to do that. Just be very careful as you do it. You know, you don't want to prick yourself. But in any case, once you get your reagent, you're going to stab the syringe through the septum and then just kind of push it into the reaction vessel. At the end of that time, you're going to let it react for, I don't know, I think it's 10, 15, 20 minutes, something like that. You're going to break down the apparatus and carry the round bottom flask into the fume hood, okay? So what you're going to end up doing is you're going to take a test tube and you're going to make a biphasic mixture of the sodium hydroxide and diethylamine. So you're going to take some 10% sodium hydroxide and then put in the diethylamine. And again, it's going to be biphasic because they're not going to be soluble in one another. What you are then going to do is take the contents, again, do this in the fume hood because it's going to get very vigorous and it's very smelly. But you're going to pipette drop-wise this reaction mixture into the test tube. Okay, it will be very, very vigorous. It's going to hiss and pop and smoke, so do it slowly. After you've added all of this into here, you're going to take the contents of the test tube and pour it back into the round bottom flask. Okay, and then you're going to let that stir for a little bit longer. All right. So just this part is the part that requires a little bit of caution because again, it is quite a vigorous reaction. Anytime you're doing anything with an acid chloride, it's a very vigorous reaction. Okay. Any questions on this for those of you who have part A? Mm-hmm.
Should we keep the test tube in an ice bath while we add the mixture?
Yeah, I would. Mm-hmm. Okay. Then those of you who have part B, you're making the same intermediate, that acid chloride, you're just doing it in a slightly different way. So who's got part B? Okay, so you guys are going to be taking the toluic acid and you're going to make the acid chloride this time using this stuff here. This is called oxalochloride with catalytic DMF. And for you, so just to, this is, you don't have to know this mechanism by any means, but I just like to show mechanisms because I think if you just show a reaction, it's just kind of a black box that nobody really ever understands. But this is kind of what's going on. You can see this is the DMF, and what happens initially is it's going to attack the oxalochloride. Ultimately, through a series of steps, you end up making this thing. And this is the actual reagent that the carboxylic acid is going to attack. So once the carboxylic acid attacks that guy, it frees a chloride, which will ultimately come in here and attack. And what that does is it liberates this thing, which gives you back the DMF catalyst. So it's a pretty cool mechanism. But anyway, you're going to combine the carboxylic acid dissolved in hexane, I believe, the oxalochloride. You're gonna do all of this in the hood and then add just a couple of drops of DMF. That's all you need. That will be a little bit of a vigorous step. Leave that in the fume hood to react. So what I'll probably do is just get a stir plate and set it in the fume hood. What you probably want to do in order to
Our screwed up ones over here.
what you're probably going to want to do, because the round bottom flask is going to have to sit and stir in the fume hood for about half an hour or so, I would probably just grab a beaker and you can set the round bottom flask in, and then you'll just kind of set that on the stir plate, and that'll just hold it in place as it reacts in the fume hood for half an hour. Okay. Other than that, I think it's fairly straightforward for those of you that have the procedure B.
So there's just, I think there were 3 of us, right, on that committee too? So we're just gonna use like all 3 teammates that are in the room, or should we go to a different room for that?
No, you can, I'll just probably set up one stir plate and all 3 of you can share that stir plate.
That makes sense.
Yeah, then.
For experiment 11 quiz, should we study the different?
No, you don't need to know all of them. It's gonna be more generalized questions.
Okay.
Yeah. Okay, then that is procedure B. The third option, method C, y'all are using a coupling agent. So we talked about this a little bit in lecture. The coupling agents are the most common way that amide bonds are formed these days. And there's a whole bunch of different ones. The one that you're going to be using specifically is one that's called HATU. It's an abbreviation for all of that. But HATU looks like this. And basically what this is going to do is this is going to activate or convert this OH group into a good leaving group. So I have the mechanism for this as well, not that you need to know it, but just so you can kind of see how this works. So basically you are converting the carboxylic acid into a good leaving group through this thing. So that thing is the good leaving group. The amine comes into attack through this intermediate, and ultimately it releases that and gives you the amide. So again, not that you really need to know that. Those of you with method C have it very easy today, because basically all you're going to be doing is mixing your reagents and putting it in your locker until next time. So you will probably be out, those of you with procedure C will probably be out within, I don't know, half an hour at best. But that said, you have a whole lot more work on Wednesday. So it's kind of, everything all kind of works out in the end. It's just, do you get the worst part of it today, or do you get the worst part of it on Wednesday?
That's why I
So,
wanted
but in any case, there's not a whole lot to say. Like I said, this reaction is very, very easy on day 1.
Manual said we're doing it in pairs, or are we doing it that way, or just alone?
No, you're doing it alone. Yeah. The only other thing that I wanted to mention, oh, by the way, sorry, one other thing. So you will end up writing a formal lab report for this, and I would like for you to consider the following things. So this is another kind of experiment, kind of like the Horner-Emmons reaction, where in your conclusion, one of the things you want to consider, in addition to the analysis of your spectra, is what is the superior method? And so again, there are a variety of things to consider when you're trying to choose a method in synthesis, and these are some of the things. Notably, percent yield, obviously a higher yielding reaction is a better reaction. How pure is your product? Well, you're not going to know that until you do the characterization next time. But you know, if you have one method that's giving you a whole bunch of garbage in your spectrum and one that's giving you pure product, well, you're going to choose a method that's giving you more pure product. How easy things are, that's sometimes a consideration. The toxicity of the reagents, that's always something to consider. And then, like everything else in life, the cost. You know, if you're dealing with a reagent that's very cheap versus a reagent that's going to be, you know, $100 per 5 grams, well, it doesn't grow on trees, you know. So, yeah, Daniel.
How will we know the cost?
You can look it up.
Okay, and how do we know ease of use? Like, are we supposed to be comparing our experiment to the other ones?
Yeah.
So like the purity of product, should we be talking to other people?
Yeah,
to
you
find
will
out?
definitely want to talk to other people that did not have your method. Kind of like with the Horner-Emmons reaction where I didn't have you analyze every single spectrum, but just know enough about them to be able to talk about it. You know, just, you might want to have grab a picture of the other methods NMR, that's going to be the one that's most useful. Just so you can kind of at least have a look at it and see, okay, well, this one is very, very clean and giving me pure product. This one's giving some product, but there's also a bunch of other garbage in here that I don't know what it is, but it's not what I want. So you don't need to analyze all the spectra, just be able to kind of talk about the other spectra in a generalized sense. Okay? Okay, so I think that is all. Oh, the last thing I wanted to tell you is, because we're doing 3 different procedures with lots of reagents today, I mean, between the 3 procedures, there are a lot of reagents out, which means a whole bunch of bottles in the fume hood. So please, 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 before you just pick up a reagent bottle and start dumping it into your round bottom flask, make sure you read the label twice. All right, you want to make sure you're adding what you intend to add. A lot of these reagents have very similar names, and if you just go into the fume hood and just with some vague idea of the reagent name and grab a bottle, there's a good chance you're going to be grabbing the wrong bottle, and that's not going to be good for you. So please make sure you are getting the reagent that you intend to get. Okay, read your bottles twice before adding. All right.